The Baylor Elmagco brake is one of the key components of the Drawworks system on drilling rigs, designed to provide braking torque and control the drum speed during lowering of drill string and heavy loads. Its operation is based on magnetic induction and the generation of eddy currents in the rotor disc connected to the drum. When electric current flows through the cylindrical magnet coils, a strong magnetic field is produced. The rotation of the disc in this field induces eddy currents, creating resistance and thus braking torque. Since there is no direct mechanical friction, the lifetime of the brake increases and maintenance requirements are reduced compared to friction brakes. However, a large amount of heat is generated during operation, which is managed by a water cooling system. Cooling water circulates through internal channels around the magnets, absorbing heat and then returning to a cooler or heat exchanger to keep the system within safe operating limits. Recently, reports were received from the driller indicating that the braking force had decreased and control of the drum had become difficult. Following these reports, mechanical and fluid checks were performed on the cooling system, including the pump and water circulation lines, and proper water flow was confirmed. Afterwards, the electrical team carried out insulation resistance testing with a megger. The results showed that one of the two cylindrical magnets had an insulation resistance near zero, indicating serious coil damage and loss of insulation integrity. Further inspection revealed that one of the wires had broken off at the base, making continued operation impossible. Since a spare magnet was available, the plan was to replace the defective magnet on board the rig. The brake assembly was dismantled and attempts were made to install the spare magnet. However, due to the slightly larger dimensions of the new magnet compared to the drum, and despite extensive efforts, it was not possible to fit it in place. Finally, the unit was prepared for shipment to a specialized workshop, where corrective work and proper installation of the magnet can be carried out with workshop-grade equipment, after which the brake will be tested and returned to service. In this video, you will see the step-by-step process from megger testing and troubleshooting to final assembly for workshop shipment. The video includes megger testing and troubleshooting, disconnecting pipes and components attached to the brake, removing the brake from its base and unbolting, moving the brake onto the cantilever, extracting the coupling, opening the covers and plates, removing the defective magnet, preparing the new magnet for installation, attempting to fit the new magnet into the drum, partial reassembly of components and final preparation for shipment to the specialized workshop.
Yeah.